Our our first speaker will be Dr. Baochun Li. That Dr. Li is a professor in the Department of Electrical and Computer Engineering at the University of Toronto. His research interests include cloud computing, large-scale data processing, data center networking, coding for distributed storage systems. So Dr. Li has authored more than 300 research papers with a total over 15,000 citations. He's a member of ACM and also a fellow of IEEE. So Dr. Li received his bachelor degree from Tsinghua University and master and a PhD degree from University of Illinois. So he will start his presentation. Dr. Li, the floor is yours.
Thank you very much, Gavin, for the introduction. Let me share my screen for the slides. Can you see my screen?
Yes, yes.
Okay, great. So thank you everyone for coming. And I just want to take a few minutes, talk about probably 20, 25 minutes, talking about agents. When I was invited to talk about something about AI, the question is, what should we talk about if we want to cover something interesting about AI? Now, that's a pretty good question, and there are no easy answers because these days, if you talk about artificial intelligence, there are many things that can be talked about. There are many, many things that are changing, and for 20 minutes or 25 minutes, it's actually a trade-off between high-level ideas and probably technical details. You don't want to be too high level. On the other hand, you probably wouldn't want to be too technical either. So if you have too much detail, probably you're going to lose your audience. And if you have too high level, probably no one really gets it. So if we have the current era of AI, the question is, what is the hottest topic today? Not one of the hottest topic, but the hottest topic today. And I would like to argue that it is agents. And that's something that I would like to briefly talk about. There are many things that have been in the news talking about multi-agent systems, agentic workflows, agentic computing. All of these are about agents. But the question is, what are these agents? What are these things? And today we would like to spend just 20 minutes probably to talk about the answer to this particular question. With some detail, but probably, hopefully, we can still fit into 20, 25 minutes. So to start, an agent can autonomously call tools and use resources. And to use resources, you still have to call tools. So the most important criteria to judge if it's an agent or not is whether or not it has the ability to call tools and whether or not it can actually do that autonomously. So for example, if we are talking about the most prevalently used agent today, which is like a coding agent, an agent can help us code. These agents can simply edit files by itself, run commands, for example, search for a string just by itself. So that's why we call it autonomously calling tools. How does it edit file? It basically have to call a tool to edit the file. So agents in general, they are just harnesses, and they're supported by a good foundation. And the foundation would be our large language models. So agents, they are just a layer on top of the large language models. Without agents, large language models will not be able to call tools by itself. But you need large language models to support these agents. Without the foundation, obviously the agents will have nothing to work with. So an agent fundamentally allows a large language model to use tool calling to get information or to take some action, to do something. So that would be like what an agent is fundamentally at a very high level. So now get into an example. So here we need an example to really understand what do we mean by an agent is a harness, the large language model is the foundation. So here we're going to use an example large language model. We're going to use OpenAI o3. We're going to use it using its API, so the OpenAI API, priced by tokens. So here's an example. At the very beginning, we will say something kind of special. We say, it's just a conversation, just an everyday dialogue, just like ChatGPT, we're using the dialogue to interact with the large language models. But we say something special. We say, you're a weather expert. When I ask you about the weather in a given location, I want you to reply with get weather location name. I will then tell you what the weather in that location is. Understood? So this particular special prompt is just a kind of like a naive way. It's an easy way to tell the agent what are the tools that we have available. So here the tool is get weather location name. That is the tool. And then the agent, the large language model o3 will tell us understood. And then we're going to continue and say, what's the weather in Hong Kong? And the agent will say, just like as we expected, get weather Hong Kong. So this basically is calling a tool. It's not directly responding to that question. It is trying to get a tool. And then we will call the tool ourselves. So I'm going to just respond hot and humid, 32 degrees Celsius. That's the result of tool calling, of getting the tool, calling the tool, and getting that result. But the large language model doesn't really care how I called the tool. It only is interested in the result. So once it's getting that result, it's able to elaborate on that result. It's going to say current conditions in Hong Kong, temperature 32 degrees Celsius, humidity high, blah, 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 just to elaborate on that result. So this is kind of like a special back and forth conversation to tell us how an agent is trying to interact with the large language model which is the agent's foundation. However, we're not doing this ourselves. Most modern large language models, they can be used for tool calling. They're actually optimized for tool calling. As an agent, I only need to do two things. The first thing is to tell the large language model what tools are available. So that's the first thing that we need. A lot of the large language models, all of the frontier models, all of the mainstream models, such as open source models, all of them, they have APIs for this. So for telling the large language model what tools are available for use. And remember our naive example, we basically use the sentence to tell the large language model that we have the get weather tool. And then the second thing that I need to do is to, when the large language model wants to call that tool that I have in my toolbox, I'm going to call the tool myself. I'm going to run the tool and then send the results back to the large language model. So the large language model itself will not be able to run the tool. I'm going to run the tool. The agent will run the tool. And then the agent is going to send the results back to the large language model. So this is kind of like the general high-level idea. However, we're not going to do this manually. So we're not going to say, okay, the large language model is going to tell me the tool, I'm going to call the tool manually by myself. No, we're going to get all of this done completely autonomously. So we're going to try to design an agent that looks like the large language model has the ability to just call tools by itself. But in fact, the large language model doesn't have the ability to do that. The agent is calling the tool on its behalf. So everything will have to be done autonomously. So we have to understand how this can be done. So to understand this, we need to spend a little bit of time. We need to know a little bit about computer programming, because these agents, they will have to be programmed to do this, because we wanted this to be done automatically. So let's try to write some code to implement an agent today, just right now, on the spot. Let's write some tools, write some code to do it. So what if I really don't know about computer programming? Well, it's okay. If you don't really know about anything about computer programming, rest assured, computer programming is not really very hard. In fact, I can actually spend just a few minutes, probably even just 1 minute, to learn computer programming right on the spot. And we're going to teach you right on the spot about computer programming. Well, to start with, all programming languages have exactly the same concepts, same elements that we should all know all about because they are sharing these same basic elements. So here are some of the basic elements. We only need to know these things for today, for the purpose of today. Let's start from Python. Python is like our typical language that we use for AI. For example, doing our agent, we're going to use Python. So here are some basic elements. If we want to print something, we just print a message. We just say, let's, call the tool, print a message. If we want to, define a tool, we need to define a function. And that we can use def. That's how we define a function. For example, if we want to define a tool to obtain a file from the file system, we just need to define the function, get file, pass in the parameter, which is called an argument typically, and that is the path to that file in the current system. And then there is an if statement, so which means that it's basically a condition. So if message.toCalls basically saying if there are toCalls existing in that message. So if that's the case, then basically we're saying that the large language model is trying to call a tool. If that is happening, then we should try to call the tool by ourselves on behalf of the large language model. So that will be a condition. So we need to understand that. And of course, we have a for loop. We could say if we have multiple toCalls, it can happen. Large language models can call multiple tools at the same time. So we could do that. So we could actually have a for loop and try to kind of iterate through all of the tools that the large language model is calling. And we can say for toCall in message.toCalls. All of that is possible. And finally, after we're done with implementing a function, we could just return. For example, we can just return error, file not found. Or if it's found, we can just return the content of reading that file. So all of that would be a basic element of any programming language. And this is not only for Python. If we have something way more complex, which is like these days the kind of so complex that even large language models may not be able to do a very good job here, which is called Rust. But however, no matter how complex this language is, it still shares exactly the same basic elements. For example, if we want to print something, there is something called print line with the exclamation mark, and that is basically just to print a message. Same thing as Python. If we want to have, for example, a function that we need to define ourselves, it is just different grammar, but we will still be able to define that function, get file. It just looks a little bit strange, but it still has an argument called path and returning a string. And if we have an if statement, if we need to decide if we need to do one thing or the other based on this condition, it just looks a little bit more strange compared to Python, but it's something that looks a little bit more complex, but it's possible, it's there. And the same applies to the for loop. In fact, for the for loop, it looks very much the same as in Python. We have for something, in something. The grammar is practically identical. And finally, the return, which is exactly the same as in Python. We just return a string, error file not found. So it's as long as you understand these basic elements, basically you just read the programming language as if it's the English language. It's pretty similar. So let's get warmed up and let's get started. And for the first thing we need to do is to create a client using a program. So how do we create a client using a program, using a computer program? Well, what is a client, first of all? So let's think about a client. So a client would be a concept that is as opposed to a server. So if you have a client, you typically will have a server as well. So the client is going to send a request to the server, and a server could be a web server, but in this case, the server would be a server that hosts the large language model. And the server is going to send the response back to the client. So the client will send a request to the large language model, which is kind of hosted typically on the server side. Even though the server could be on your own machine in your laptop computer, it is still operating as a server. And the server is going to send the response back. So we're going to use this paradigm of what we call a client-server architecture, or we can call it the request response model, to actually try to implement our agent. So here's how we initialize the client. So here we're importing the API from OpenAI. In Python, it's basically saying from OpenAI, import OpenAI. And then we're going to just use that OpenAI to just call it to create a client. And that client is already implemented by OpenAI in its application programming interface or API. And we just directly use that API to obtain our client. So once we get the client, it has the ability to talk to OpenAI's servers. And the second step is to implement your tools. So how do we do that? Well, we need to have the ability to implement a function, because each tool would be a function. And in Python, we just mentioned that in our primer. So we just need to use the def. So the def is going to define a function. Let's call it the get file function. So the get file function takes one argument, which is the path to the file system in your computer or anywhere. And then it will just open that file and it will return the content of reading that file. So again, this is Python, but as long as you kind of understand the basic idea of having a function and returning from a function, this pretty much reads like the English language. Nothing special to something like this. So we're going to define a tool function here. And then the third step, which is very important, is to define what tools that you have in your toolbox that can be offered for the large language model to call. So we need to tell the large language model what tools do we have. And remember, in the get weather example, we basically just say, I'm going to tell you I have get weather here. And here, we're not going to do that. We're going to do it in programs, in our Python program. So to do that, we're going to define something that is a dictionary. This is a dictionary in Python. The dictionary is basically a bunch of keys, and each key has a value. It's basically a key value mapping. So here, we're basically saying we have the tools, which is basically a set of dictionaries and a list of dictionaries, and each dictionary is one such tool. And here we only have one, which is having a name of get file, having a description of getting the contents of a file. That description is very helpful for the large language model to understand what that function is doing. And then we have a parameter, which is the path, and that's just a single parameter, and that is required. And then we're going to have to define what that parameter is, which is basically a string. And what does it do? Well, it provides the path to the file. So this is basically a special way. It's like a dictionary. It's a special way to tell the large language model what tools that we have. So that's really useful. And then we're going to use our client to send an initial request, the very first request, to the large language model. So in this initial request, we need to have a message, and that message takes the role of a user. So the role would be a user. And the content of that message would be just like a prompt. Please open the file example.txt using the get file tool. So typically, large language models are pretty smart. You don't even have to say using the get file tool. It will directly use that tool. Because the get file tool has a description, and that description is saying, I'm here, I'm available to open the file. So if you just say, please open the file, it should be able to use that tool. So here, I'm just getting a little bit more explicit here. And then I'm going to use the OpenAI client, one of the functions called chatCompletions.create, to really try to create a message, basically a request. And that request will be sent to the OpenAI server. And that request contains the message. That is the role user, and the content, please open the file example.txt. And also it contains the tools. Remember, the dictionary we just defined, and that's the tool that we pass in to this create as well. And then we get the response from calling the OpenAI server directly. So that request is sent, and we basically get the response, and we take the first choice from that response. Choice is zero. Zero is the index for the very first choice. And then we try to get that response processed, which is the message. And how do we do that? Well, we're going to process that response from the large language model, and we're going to take a look at the content of that response. We're going to say, does it really try to call a tool? And most likely the large language model will try to call a tool because we're basically saying, please use the get file tool. So it will try to call a tool. So what it does is that it will have something called message.toCalls. So we're going to use our if statement to try to decide whether or not the message contains a tool call. So if it does contain a tool call, what we will do is that we will construct something called an assistant message. And that assistant message, we will put the actual tool call into that message, including several things. Its unique ID, the type of the tool call, and the function that the large language model is trying to use, which tool it's trying to call, and of course, the argument that the large language model is trying to pass. Example.txt, that's the file name. That would be the argument. So we're going to use that, and in the for loop. In the for loop, we're going to basically iterate through all of the tools the large language model is trying to call. And if that message contains a tool call, we were going to put that into the assistant message. So the assistant message will be appended at the very top, very bottom, line number 75. We're going to append that to the conversation history. So we'll not only have the user message, but also the assistant message just to help the large language model. And then we're going to call the tool ourselves. Remember, we're going to have to call get weather ourselves. This is exactly what we're going to do, but we're going to do it in the program as in Python. We're going to call the tool, and we're going to embed the result into the next request in the assistant message. So what we're going to do is that we're going to try to say, okay, let's do a for loop through all of the tools that the large language model had called, and we only understand one function name, which is get file. If they called get file, we're going to try to get the argument. We're going to try to get that get file called. We're going to call get file directly with the path. Path would be the argument. And then we're going to try to take the result of calling that tool and try to append that to the message. And that would be with the role of tool. So we also append the unique ID of that tool call, which is the actual ID that the first response, the large language model is sending back to me. I'm going to use that ID so that the large language model will know that this is the result of calling that particular tool. All right, so we're going to have that ID to match the response with the actual tool call. And then finally, we're going to send that request, which contains the user message, the assistant message, and tools to the actual large language model and print its response. So that's the basic idea. We're going to print the response, and that will be the response that is the first choice. We're going to print the content of the message, and that will be the response that we have. So that's 100 lines of code. So the question is, how do we run it? Well, we're going to run it directly by just running Python. Python, for example, let's call it agent.py. It turns out that the agent.py, as long as you give it the API key, it will automatically send the request, which is get the content of example.txt directly to the OpenAI server, completely autonomously with no interaction whatsoever, and they will give me the result of the final response from the large language model, hiding everything in the middle. Everything in the middle is completely automatic and just getting me the result, which is the comment of the file example.txt is hello world. So that is the response from the OpenAI O3 model. And that's completely automatic. So our agent.py, even though it only had 100 lines of code, and I have shown all of the code in the slides, it is an agent. It's the precise definition. It's one example of an agent. So that's it. That's everything I would like to talk about today. And I hope that you enjoyed this 20-minute show of an instant primer to agents. Thank you. And I'll be happy to answer any questions that you have.
Thank you very much, Dr. Lee. Very wonderful presentation. and also including a very hands-on actually example. So it's worth mentioning that Dr. Lee also the chair of the scientific committee of the CAIO. So here we get some questions from the audience. So one question is that someone asked, so AI is not a single discipline. If one wants to study AI, should they major in computer science? What are the difference and connections between AI studies and computer science?
Oh, that's a fantastic question. Computer science is indeed the discipline that encapsulates most of uh, the current research in artificial intelligence. So if you talk about the specific, area of artificial intelligence, for example, just machine learning, or even narrower area like supervised machine learning or reinforcement learning, these are obviously part of computer science. However, AI could be, if you just talk about in general, AI could be related to computer engineering and other disciplines as well. For example, if you're talking about hardware design, which is a very hot topic today, and how do we accelerate AI, kind of operations such as matrix multiplications using hardware, that is going to be more in the domain of computer engineering. So I would say probably computer science and engineering would be more of a fitting description to like the discipline that encapsulates all of the AI.
Thank you very much, Dr. Lee. And the second question we got is that should we still learn the programming language today, considering the power of agents these days, right? So, which program language do you recommend the most?
Mhm. That's a fantastic question. That's a great question. I deal with this every day. So all of the large companies these days, the frontier AI companies such as OpenAI, Anthropic, and so on, they have publicly mentioned that they use AI for probably 80%, or some people say up to 95% of their internal programming development. But that's still not 100%. So in other words, all of them, what they're doing is that they're taking an approach that I call human in the loop. So you're going to have to really try to guide the AI to do the development. So obviously, agents, for example, coding agents, is very capable of everyday programming. However, it is not kind of perfect. And that is reflecting all of my recent, personal experience. Programming is hard. It's not easy. So AI can do like 90% or 95% even of the work, but there's still a lot of work. 5% of that would require humans to be in the loop. However, if you know nothing about programming, it's very difficult to stay in that loop and guide the AI properly. However, if you don't learn programming, you will not be able to eventually have the ability to guide the AI. So or to pass judgment on which generated code is correct and which one is a good design and which one is incorrect. So AI can make mistakes. In fact, they make plenty of mistakes, and you're going to have to figure out which mistake is something that you need to correct. And what are the things that you need to directly throw out. So that requires a lot of experience in programming. So I would argue that until the day comes where the AI can do 100% of the programming, you will still have to learn. And the best programming language would be three languages of my favorites: Python, TypeScript, and Rust. These are the best languages that I think everybody should know.
Thank you very much, Dr. Lee. So considering the tight schedule, we may have one last question. So
Sure.
this is also a very interesting question. So as a professor who has achieved a remarkable research success, how did you choose your own research direction? And what criteria do you use when selecting students?
Well, this is basically two questions. How do I
Yeah.
choose my research direction? So I would love to choose something that excites me. So this would be something that really inspires me. Exploring the unknown is quite exciting. However, there are always resource constraints. For example, if you're talking about AI research, a lot of the topics require a lot of hardware resources, which I may not actually have. So within the constraints of resources, I would love to be kind of get excited and inspired by the actual topic that I'm exploring. So I change the topic from time to time, mostly based on that particular criteria. And the second is, how do I choose students? I would love to choose students who can collaborate with me kind of very well, in the sense that I would love to be able to co-author with my students, working very closely together and try to crack something hard. I would love to work with students who prefer to work with me closely. So I think that's one of the things I pay a lot of attention.
Thank you very much, Dr. Lee. And so let's give just a